So, hello! Today I'll be discussing everything in our solar system, such as the classification of objects, the order that these objects are found in our galaxy, the possibility of colonizing Mars, and even how far in our galaxy, the Milky Way, we can explore. Before we start, please note that this is not in the GCSE spectrum, but it would be good if you'd know the basics of our solar system. So, talking about the basics, let's just go over what a solar system is and what the planets and other objects in our solar system are. A solar system is everything that orbits a star. In our case, it is everything orbiting the Sun. So this includes the Sun itself. After all, what is the solar system without a star? Mercury, the closest planet to the Sun and also the smallest, with a year on the planet lasting only 88 days because it's so close to the Sun that orbits take less time. Venus, the clouds you see in this picture are actually sulfuric gas obscuring the 462 degrees Celsius surface. In fact, it is the hottest planet in our solar system. Earth, the only planet yet discovered with life, which I'm sure you know all about. Mars, the closest planet to us and a possible place for colonization in the future, since water exists as ice there. The main asteroid belt is a circumstellar disk between Mars and Jupiter, which has many irregular-shaped asteroids, also known as minor planets. Jupiter, the closest gas giant to the Sun. A gas giant is a large planet made mostly of gas. In this case, Jupiter is comprised of mostly hydrogen and helium. Saturn, another gas giant, this time with a ring of asteroids around it, which was actually formed when one of its moons formed too close and broke up into little pieces. Uranus, the seventh planet, also known as the rolling planet because of its 98-degree tilt, again another gas giant. Neptune, the last of the gas giants, named after the Roman god of the sea, like many other planets are named after gods. The Kuiper belt, made from the ice's methane, nitrogen, ammonia, and water because of how far away the Sun it is and how cold it is. And lastly, Pluto, the last object in our solar system, which is classified as a dwarf planet not so long ago because it was too small. There are actually more dwarf planets, but we tend to stop with Pluto. So, that's everything in our solar system. If you want an acronym to remember that, then you can say, "My very educated mother just served us 9 pizzas." But to be honest, I never really liked acronyms. After researching this, though, I actually realised how many different types of planets there are, and objects in our solar system. So I'm now going to explain why the planets are ordered in this way. There are 4 rocky planets, Mercury, Venus, Earth and Mars, and there are 4 gas giants, Jupiter, Saturn, Uranus and Neptune, separated from the rocky planets by an asteroid belt, and on the other end is a dwarf planet named Pluto. The rocky planets are small, but they are also very dense. This is because they are close to the Sun, and this means volatiles, like gases, like water and methane, couldn't condense because it was too hot. On the other side, where it's less hot, the gas giants formed from these volatiles, making them huge. Now, why are there asteroid belts though, and why haven't they formed into planets? The asteroid belts are left over from the creation of our solar system, because they haven't formed into planets yet. This is because Jupiter's gravitational field disturbs the disk shape as it orbits around the Sun. When it gets near the asteroid belt, it pulls the asteroids, and this creates gaps called Kirkwood gaps in the belt and prevents the belt from forming into planets. But I said before, Pluto isn't a planet, but why? Well, there's been quite a lot of debate And actually, NASA decided that it's going to be called a dwarf planet, because actually it's just a large asteroid, not big enough to be called a planet. Well, NASA's correct classification of a planet is that 1, it must orbit the Sun, and 2, have enough gravity to be round, which it both succeeds in. But 3, it has not cleared its neighbourhood of asteroids around it, and so it is not distinctly a planet and can be compared to asteroids. So I have a list of things that I must include in each video, and one of them is where could humans escape to in case of a large asteroid impact? Well, I'm going to make this brief because there's no chance of us sending a spaceship to colonise Mars or any other planets with the technology we have now and with such little notice. The best bet would be to make an underground, self-sustaining dome where we can stay for a few hundred years after the Ice Age has ended. If you're lucky though, the impact may be fairly localised and not affect you if it's on the other side of the globe. But if there weren't an asteroid collision and we just run out of room, what's the chance of us being able to colonise Mars? Well, actually, we may, in 2030. NASA say that they've made a plan to set up an Earth-independent habitat on Mars. No, Earth-dependent, sorry, there's a big difference. But if given more time, we could begin terraforming with one method using organisms like cyanobacteria and phytoplankton to convert CO2 into O2. The low pressure could be solved by raising temperature, thus melting the ice in the South Pole and turning it into CO2, and increasing the pressure. Or we could even live underground. But the important thing is, will it be beneficial? Well, we would have a lot of room, enough water in the form of ice, lots of mineral to mine and sell, and also a large economy to be made from a housing business. But the problems are still too much at the current state of our technology, like radiation, little breathing air, low gravity, high surface temperatures, but they're not insurmountable. But I'll leave that for another day. Now we widen our range to our galaxy, the Milky Way. There are 100 billion stars and another 10 billion galaxies in our universe that we know of. But we've only reached the moon. We've sent out robots up to 11 billion miles away. 11 billion. But the only way we can discover things outside of our solar system is by telescopes. The most powerful being the Hubble telescope. But even the Hubble telescope can't reach as far as the centre of the galaxy, in which the galaxy actually orbits. But if we use infrared wavelengths that can pass through the dust blocking us, as opposed to optical light, we believe there is the largest black hole in our galaxy. But we can't be certain until we actually see it with our own eyes. So, that concludes this video. I'm sorry if it's been a bit too long, but don't worry, because you don't have to remember everything. It's just good if you understood it. Thanks for watching.